Hello dear students, today we are going to start with surface integral. First one, what do you mean by the surface integral? If the integration depends on the surface is called surface integral. So let us see that the basic concept of the surface integral. Here the surface integral over a curved surface S in the generalization of a double integral over a plane region R. Let the vector field F1 is equal F1i plus F2j plus F3k, where I, j, and k are the unit vectors. D. A continuous vector point function defined over a two-sided surface S. Now divide S into a finite number of subsurfaces, say S1, S2 up to Sn, with surface area delta S1, delta S2, delta S3, and delta Sn. Now let us consider the small portion of the surface, say delta SR with the surface area of SR, and R cap is the unit vector at some point PR in SR in the direction of the outward normal to SR. It means that N cap R is nothing but unit normal vector to the surface at the particular point. Now, if we increase the number of subsurfaces and the surface area delta SR of each subsurface will decrease. Thus, as m tends to infinite, delta SR tends to be 0. Then, also we know that integration is nothing but sum of all the partitions. So, we are extending that concept to the double integration. So, limit m tends to infinite sin r is equal 1 to n f of pr dot nr cap delta sr. Again, this will be the same as double integration over the surface as vector field fr dot n cap ds. And this integral is called surface integral over vector field f over the surface s. Equivalently, also we can write the double integration of the vector field f dot n cap ds over the surface s, or simply you can say that double integration of the vector field fy over the surface s is given by double integration f dot ds bar. So whenever you compare these two double integrals, so you can note that ds bar is nothing but n cap ds. Also, if it is given that the surface as an equation, so we can say phi of xyz equal to 0 is the level surface, or you can say equation of the surface, then uncap will be, unit normal will be grade of phi divided by its mod. Now, also we have studied about that the flux, if F1 represents velocity of the fluid at a point P on the surface S, then the surface integral, so we write a double integration F dot n cap ds represent the flux of F bar over S. Here the volume, it means that volume of the fluid flowing out from S per unit time. Also, we already studied that double integration over the surface as f dot n cap ds equal to 0. Then we can say that the vector field F1 is called solenoidal vector field. Also, we have studied that the solenoidal vector field, it means that if divergence of F1 is equal 0, then the vector field F1 is called solenoidal. So now we are going to focus on that how to evaluate the surface integral. So here a surface integral is evaluated by expressing it as double integral over the region R. So here it is given that this is the surface S, and we have assumed that this is a small portion of this surface S. It is denoted by ds. And also we can note that k cap is nothing but parallel to outward normal, that we can say z, and n cap is the unit normal vector at that particular point. And whenever we take the projection on the xy plane, so this will be your region R. So similarly, the region R is the orthogonal projection of S on one of the coordinate planes xy, yz or z. Let us take the R, let R be the orthogonal projection of S on the xy plane, and cos alpha, cos beta and cos gamma are the direction cosine of n cap. That is the standard form. Then n cap can be written as cos alpha I plus cos beta z plus cos gamma k. So in that case, whenever we assume that the projection on the xy plane, so dx dy is what? That is the projection of ds on xy plane. So this can be written as ds dot cos gamma, where gamma is the acute angle which the normal end at p to the surface as makes the end makes with z axis. It means that it is going to be make angle with this. So this will be what? Our gamma angle. So therefore cos gamma can be written as what? Mod of n cap dot k cap, where k is the unit normal along to z axis. Similarly, we can note it from this ds as a subject, so we can have dx divided by cos gamma, and again cos gamma is replaced by this form. So we have ds is equal dx divided by mod of n cap dot k cap. Hence, our surface integral f dot n cap ds, it will be same as double integration f dot n cap dx dy divided by mod of n cap dot k cap. Similarly, taking the projection of yz and zx plane, we can have the formula number. If I say this is the one and another, this is the formula number two for the zx plane. Now let us see the simple question. Double integration over f. Let us see the simple question. Evaluate double integration f dot n cap ds over the surface S, where f bar is given by 18zi plus 12z plus 3yk, and S is the part of the plane 2x 2y plus cz is equal to 12 in the first octet. So this is our x-axis, this is y-axis, and this is the z-axis. So here, whenever you're supposed to do this figure, so what I'm just going to consider, just divide by 12 on the both the sides. So we will have 2x divided by 12 plus 3y divided by 12 plus 6z divided by 12 equal to 12 divided by 12. So here you can notice that x divided by 6 plus y divided by 4 plus z divided by 2 equal to 1. So here coordinate of x will be 6 comma 0 0. So from this it is going to, and for y coordinate you can say this is 0 comma 4 comma 0, and z coordinate that is 0 comma 0 comma 2. So this is our figure. So here first one, the surface integral is in the plane. So whatever we have given, so just mention it in the first octet. Let phi is equal to x plus 3y plus 6z minus 12 equal to 0. So this is the surface. So from this we can find unit vector and k is equal grade phi divided by mod of grade phi. But grade phi is what? Del phi by del x I plus del phi by del y z plus del phi by del z k. So from this we can get the 2x plus 3z plus 6z divided by its length. So what it will be? So in that case square root of 4 plus 9 plus 36. That will be square root of 49, and square root of 49 is 37. So we have this is the unit vector. Now let the projection, let R be the projection of the plane, this one plane in the first octane on the xy plane, that is a triangular. So you can notice that this is our x-axis and this is the y-axis. So this is the line y is equal 0 and this is the line x is equal 0. So this line will be what? That is the 2x plus 3y is equal to 12. Simply you are taking the z is equal 0. If I'm substituting z is equal to 0, so I will get this one equation. So ds can be written as what? Dx divided by mod of n cap dot k cap, where n cap is nothing but unit normal vector to the given surface that we have obtained here. So let us replace over here, and k cap is what? So whatever we are taking the project from the xy plane, So perpendicular to that we have that is the k cap. So we can write here k cap. Now just take the dot product. So what you will get only 6 by 7 in the denominator. So at the end, denominator of the denominator is going to be numerator. So we will have 7 by 6 dx dy. So this is our ds. Now for the reason are the limits are. Here we want the first limit for y. It means that we are taking the straight parallel to y axis. So our bottom is that is y is equal 0 and top is what from this we can make y as a subject. So it will be 12 minus 2x divided by 3. So here y is equal 12 minus 2x divided by 3 and limit for x will be 1. So here we can notice that is straight parallel to y-axis that we can consider from x is equal 0 to x is equal. This is what? 6. This point is 6 comma 0 and this point is 0 comma 4. So we can consider the straight parallel to y-axis. It is starting from x is equal 0 to x is equal 6. That you can realize from this figure. So we have this is the limit for x. Now let us see that how we can solve this double integration. So whatever we have found that whatever we are given that FR, this is the uncap, and whatever we have ds, so we are going to replace over here. Now let us simplify. So I dot I, so it will be only 1. So 18z into 2, so that is the 36z minus 12 into 3. So it will be minus 36 plus 3y and into k. So we have 18 1. Then dx divides that. And whatever we have, this is 7 is going to be cancelled out and 1 and 6 will be common from this double integration. Now we are given that this is surface, so from this z can be written as 12 minus 2x minus 3y divided by 6. So let us replace over here. So we will have after simplifying this one, and again you can notice that 12 minus 6 it will be 6. 2x is also there, so just let us put over here. This 3y will be the cancel out. So whatever we have that assume the limit. So let us put over here. So this is the first limit for y and outer limit for the x. And after integrating, so this is what our constant function for y, because we are first doing the integration with respect to y. So integration will be only y 0 to 12 minus 2x divided by 3 and then dx is also there. So let us put the first upper limit. So we have 12 minus 2x divided by 3 and after simplifying we will get this one, and as we know that how to perform that integration and after putting the limit you will get the answer that is the 24. So we have obtained that double integration of the vector field S over the surface S, that is the 24. Let us see the another example. It is an interesting question. Given a double integration of vector field Fr into n cap ds over the surface S, where Fr is given and S is the surface, y square is equal 5x. So here you can see that this is what our surface, y square is equal 5x in the positive obtained bounded by the plane. This is x is equal 3 and this is what z is equal 4. So having this boundary, we have this one figure. So here what we have given, surface that is y is equal y square minus 5x is equal 0. So from this we can find that the unit vector n cap. Now let the projection of the surface on the positive obtained bounded by the planes x is equal 3 and z is equal 4 in xz plane. So we are taking the projection and xz plane. So dz can be written as dx dz divided by mod of n cap dot j cap. Here n cap that is we have, so replace over here, just take its dot product and after simplifying you will get this one down. Square root 24 plus 4y square divided by 2y into dx dz. Now the whenever we take the projection on the xy plane, xz plane, so we have for that reason the limits for x that is 0 to 3 and again the limit for z it will be 0 to 4. Now let us see that how to find out this double integration. So here f is given and that we have found and ds is also where there are. Substitute all this value and you can notice that this term is going to be cancelled out. After simplifying, you can notice that the y is also, 2y is also there. I haven't seen that. But whenever I take dot product of these two vectors, so it will be minus 15y plus 4yz and into 1 divided by 2y dx dz. Now, whatever we have that assume the limit for x is equal 0 to 3 and z is equal that is 0 to 4. And after integrating, we will obtain that this one. And after simplifying all these terms, you will get the answer that is the minus 42. Thank you.